HVAC charging refrigerant, high superheat, low subcooling, the mathematics of it, it's fairly simple. There may be a formula: superheat minus line minus gauge. So if one takes and goes over here, this is the outside, the PSIG. So if we're hypothetically dealing with R22 refrigerant, we scale up here and we say at 55 degrees we're at roughly 55, the outer one, cross-reference this across, we're at roughly 45 degrees. So now, as we note, when the PSIG, when the suction pressure lowers, it seems like the temperature lowers. Anything below 32 is going to be taboo because it could cause the A coil to freeze. And once the A coil freezes, you're not getting proper airflow across the A coil. Moreover, when the A coil freezes, and perhaps if you have a split unit and you go outside and you notice the high pressure line outside has frost or ice on it, or even worse, even the condenser, perhaps, I'm not sure if it would freeze too, but so anyway, hypothetically, or realistically, we want to stay above the 32 mark, 32 degree Fahrenheit mark. So somewhere in here may be good, the 40 or 50. So this would read on the suction side, say 55 PSIG, maybe if we cross-reference it to the degrees temperature, maybe about 45. So if we take this and extrapolate this data to a simple formula, superheat minus line minus gauge, we have the temperature on the gauge. So when the gauge here, line minus gauge, say the temperature on the gauge hypothetically was 60 degrees, the temperature on the temperature was 30. So 60 minus 30, that's 30 degrees superheat. That would be a high superheat, which would mean this would be, okay, if we took the same formula and plugged it in, say 60 degrees, the line temperature, the big line, the one with the, say the insulation on it, the larger of the two lines if it were a split unit, and the temperature from the gauge is 45. So if we take 60 minus 45, this gives us a superheat of 15 degrees. With a piston unit, this may be a good superheat, so this may be good. So as one can see, the 30 may be high. So as we see, the higher the superheat, the lower the suction pressure. So because if we cross this around, it's like, and it's just a matter of this number here and really this number here. Because if we take these numbers here and we subtract these numbers, once these numbers, we can see the difference between the end result. It's just a little simple mathematical formula. And so basically 60 minus 30 is going to be 30. That would be 30 degrees superheat. That would be too high. So 30 degrees superheat would mean this would be 30. So if we cross-reference this over on 30 on the gauge, this would be about 52, 51, 52 PSIG. So which means a low suction pressure, as we said earlier, may vary inversely with a high superheat. So if a high superheat, when we have a high superheat, the suction pressure may be low. So hypothetically here, if we take this formula here and we take 45, say the line temperature, the larger line outside, the copper line, the one with the insulation on it, was 60 degrees, and we cross-reference this over here on the gauge at, say, 45. So we come across here, realistically, we note that the pressure here is higher, so 45, and then we go here and we say 60 minus 45 equals 15 degrees superheat. So this is more in line what we're looking for. So a high superheat may be when one has a high superheat, this means the suction pressure may be lower. So, for instance, on this number here, say we have a high superheat, this would be the superheat number here. So if we took this over, this number here, and moved it over on the gauges at 30 degrees, we would have, let's see here, if we go to the gauges on 30, and we go over, we're at 51 or 52. So it means a higher number here usually means a lower number here. And then you just push these in. These are the same formulas, but just doing this as an example. So for instance, this would technically be around 50, 51, 52 psig. So the lower your suction pressure, this would be your suction pressure. The lower your suction pressure, the higher your superheat. So I guess they kind of vary inversely. So when you have a low on one, you have a high. When you have a high superheat, you have a low. But what I'm trying to do here is just show how the numbers tell this information. So basically, let's rehash one more time. Superheat, line minus gauge, a little simple formula. Say the line temperature outside the copper line 60 degrees. We go to the gauge here. The gauge is reading, say, 51, 52 degrees. We're using R22. We come across here. We have to say 30 degrees. Say 51 degrees. So then we take this 30 to 60 minus 30 is 30 degrees superheat. It's too high. We take this formula, the same formula, we're just doing the same formula, just hypothetically punching in different numbers. We go 60 minus 45. So 45 may be a good number. As you notice, 45 here may mean about 55 psig. So this would be from your gauge, the number from your gauge if you were using the old manifold gauges. If you're using the digital, it'll calculate it, but it's good to know this stuff. So if you take 60 minus 45, we have 15 degrees superheat. That may be a good number if you have a piston unit. So as we see, the higher the superheat, the lower the suction pressure. So again, this is this number here. 30 is 30 here is our superheat. 30 here is our temperature. If we cross-reference it over to the psig, that means whatever the gauge says here. So if we have a high, if we have a low suction pressure, we have a high superheat. And you see as it scales up, as the numbers go up, it's more in line. So this number here goes up, the 30 to the 45. The 45 number goes up in temperature, so we're going up on psig. So on the psig at 45, we would read, say 45, we would be at about 55 psig. So this would be 60 minus 45, 15 degrees. So just a little mathematical formula to hopefully start to understand why these numbers, a low suction pressure could mean many things, but it could mean a little bit, you need some refrigerant, a little bit of refrigerant measured correctly. So you need these numbers here to get your refrigerant if it's a piston unit. So basically, but these numbers, I just laid out two examples to explain how these numbers, so if your superheat is high, usually your psig, your suction pressure is low. So if you come out here and you hook the gauges up, and when you hook the gauges up, if your pressure is below 51 to 52, there's a high probability that you may already see frost on the lines, but and if this number here is not now, if there's a leak in the system, the leak needs to be repaired. But if there's not a leak, and then the system needs a little bit of boost of refrigerant, then this number here needs to get up below 32, preferably 40, 45, somewhere in that range. But if it's 32, it's going to freeze. So it's going to your A coil will begin to freeze. Hope this information makes sense, and thank you for watching. If you find any of these videos helpful or tidbits of information useful, please like, share, and subscribe, and have a wonderful day.